Okay. All right, so 2.8, which is the last thing in section 2 of this outline. Basically, section 2 is just sort of going over the logistical details of pointers. Arrays, let me put it this way, in C++, arrays and pointers are the same thing. Okay, so that's sort of the overarching fact that I'm going to try to communicate. It actually turns out that that's a slight simplification, but it's a simplification in the direction that students usually miss. So I'm going to leave it like that for now, and we'll talk about the minutia in a few minutes here. But basically what that means, and this is not a difficult concept, but it seems like students understand it, but then they have a hard time just sort of thinking in these terms. When you're programming and you're using an array, in your brain you should be thinking this is an array, but it's also a pointer. When you're using a pointer, you should be thinking this is a pointer, but it's also an array. You'll see what I mean as we go here. So the next thing I want to say in terms of just sort of trying to draw this out, what we typically refer to as an array in C++. I see that I've sort of shot myself in the foot here by making this so small. Maybe I can just make it a little bit small, making it so big on it. Okay, what we typically refer to as an array in C++ is actually, in terms of what's actually going on in the computer's memory, a pointer to an array. So if I were to draw a picture of this, let's say I have a declaration like int my array 10. Okay. Up until now, the way that I would draw a picture of that would be I would say, here's the variable my array, and I would 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my array. I've got indices, and there's my array. Okay. That's a pretty good way of looking at it when you're doing basic stuff, but it's not technically correct. The technically correct way to draw this would be, here's my variable my array. It is a pointer to an array. Okay. Okay, so what that means is that when I use the square brackets, it's actually not just indexing the array, it's actually dereferencing the pointer and then indexing the array. So if I say, for example, my array sub 3 gets 27, what's happening here is the compiler is going to say, okay, I first need to dereference the variable my array. That puts me here. And then I need to move down 3 spots in the array. 1, 2, 3. So put the 27 there. Okay. So, no one actually calls it this, but I think if you were trying to be very precise, you might call the square brackets the dereference, and if I can spell, dereference and then move over operator. Does that make sense why I would call it that? Wouldn't that be 4 spaces moved? Well, if you dereference my array, that gives you this memory location right here, the one that I just turned yellow. That's what you get if you dereference my array. So now I'm saying, well, there's a 3 in the square bracket, so move over 3 elements. 1, 2, 3. So I moved 3 spaces. Any other questions about that? Okay. Does it make sense why I would say it's, so first of all, let me just back up a little bit. The square brackets in C++ are actually operators, just like plus is an operator or the extraction operator is an operator, right? And you know, it's not like the semicolon, right? The semicolon is not an operator, it's a syntactic device. But the square brackets are actually an operator. And I would describe them, I guess, as the dereference and then move over operator. That's if I am trying to describe it in terms of what it actually does. All right, any questions so far? Okay, so what I mean when I say that pointers and arrays are the same thing, you can use them interchangeably. Once you've got a pointer or once you've got an array, you can choose whether you want to use array syntax or pointer syntax on it. Either one is fine, doesn't matter. Okay, so if I wanted to set this yellow cell right here to 35, normally what we would say is we would say my array sub 0 equals 35, right? That would be using array notation, which makes sense because we declared it using array notation. However, my array isn't just an array, it's also a pointer. So another way to put a 35 in that same location would be to say star my array gets 35. Same thing. How's that sound? Anybody want to ask a question? Just tell me that that seems completely crazy. I mean, I think this is one of those things about C++ is actually pretty cool once you get used to it. Takes a little bit of getting used to. So don't kick yourself too hard if it takes you a while to get used to this idea. But there you have it.
Excuse me.
Mm-hmm.
Why is not like a star my array 0 equal 35?
Well, let's look at my picture here. Okay. If I say star my array, what the star means, follow the arrow and give me the memory location that the arrow is pointing at, right? So if I just say star my array, that means this yellow cell right here. I'm not sure how, I'm not sure how, I mean, I guess what's behind your question is you're thinking, wait a minute, my array isn't a pointer, it's an array, right? You wouldn't have asked me that question if you were thinking of my array as a pointer, but you're not. You're thinking of my array as an array. Does that make sense?
Yes.
Okay. So, you know, if you tried to say, and let me answer that question another way. The square brackets already dereference, right? So if I say star my array and then brackets 0, that would mean that I'm trying to dereference twice. Yes, the answer to your question, Martin, is yes. That's 2 different ways of saying the same thing right there. Okay. Anybody want to ask another question? I mean, I find this actually the process of seeing this for the first time is actually super fascinating, because every time I do this, I get that same sort of question, like, wait a minute, I'm still not quite seeing this array as though it's a pointer. Or wait a minute, I'm still not quite seeing this pointer as if it's an array. You just have to kind of, I don't know what the word is, leap of faith, whatever. They're the same thing. Okay, let me see what else I want to do here. Let's take my pointer variable now, and let's assign it to my array. Take a look at that assignment. Let's see. So how would we access the rest of the slots in my array with my array? Okay, that's a great question. I will stop where I was going, and I will take a minute and answer that question. My first answer to that question is you probably wouldn't. In fact, I'm going to show you how you can actually do that, but I'm also going to say, please don't do this, because if you want to access, my array sub 8, doing it using pointer syntax is not the best. It's clunky. Okay, that's why we have array notation. But just so you know that it's possible, let's take a look. Let's say I want to put the number 101 right there in slot 8. Okay, here's how I could do that. Okay, so this is, wait, yeah, this is go to memory location, my array plus 8. So here's memory location, my array. So memory location, my array plus 8 will be this memory location. Okay, but this thing in the parentheses is not a value, it's a memory location, right? I took the memory location, so, just to pick kind of a silly number, but let's say that this yellow cell right here is memory location 1000. So what I'm saying here is go to memory location, or use, not go to, I shouldn't say go to. Instead of having the number 1000 in the parentheses, I've got the number 1008. And then when I put the star in front, that means, okay, go to that memory location and give me what's being stored there, right? So let's just do some COUTs here so we can actually, I just noticed I haven't done a single COUT statement here. Yes, this is pointer arithmetic, exactly. Anytime you have a pointer and you do plus or minus with the pointer, that would be pointer arithmetic, which there will certainly be times in your programming life when you will want to do pointer arithmetic, but I'll just say right now that it will not be in this class. It doesn't matter the byte size or the type. Okay, good question. When I say my array plus 8, I am not saying my array plus 8 bytes. I'm saying my array plus 8, however big those elements of the array are. Okay, same thing with the square brackets, right? When I say my array sub 3, I'm not saying move over 3 bytes. I'm saying move over 3, however big those array elements are. So C++ automatically knows how to move over one array element. Okay, let's do some COUTs here. What should I COUT? I could say COUT my array. That'll give me the memory location of the yellow box. I can say COUT star my array. That'll give me the 35, right? I could say COUT my array plus 8. Okay, so that should, whoops, plus 8. So we may or may not be able to easily examine that and see that this line of output is going to be line 30's line of output plus 8 integer sizes. I think integers are 4. Well, let's just see what happens. And then I'm going to say COUT star my array plus 8. Okay, if anyone has any other suggestions for what you'd like to see printed out, let me know. All right, so let's compile this. I did a lot of typing, so I'm guessing I'm probably gonna have at least one syntax error in there somewhere. Oh, nope, good. Data out. Okay, so here's the memory address of the yellow square. Here's the memory address of when I add 8 of those things to it, 8 of those array elements. Looks like I actually added hexadecimal 20, which is actually 32, which makes sense if each integer is 4 bytes. So I added 32 to the memory location. Any questions about that? This is one of the things you may want to come back later and look at this video and just go through this again in slow motion if you need to. The other thing I should just do is if I say my array set 8, these 2 lines of code are equivalent, right? In fact, when the compiler translates this code into machine language, both of those 2 lines of code are going to get translated into the exact same machine language. So just to do it one more time, I get the, oops, didn't say that, yeah. I should get that same 101 twice now, right? Okay. All right, any questions so far? Basically what I'm going to do is I'm going to just spend some more time throwing some random code out here that shows using arrays as pointers and pointers as arrays and using them interchangeably. Oh yeah, so I was doing an example when someone asked a very interesting question. So let's go back to that. I'm going to say pointer gets my array. All right, so I want you to just stare at that for a minute. I don't want to just babble on about and tell you what that means. Is that mysterious looking, or does that seem pretty straightforward in terms of figuring out what effect that is going to have on our picture? Take 30 seconds and decide for yourself, what effect is that going to have on my picture? Don't answer, just think about it. All right, so if someone's chomping at the bit, you want to go ahead and answer that either in the chat or out loud, that would be fine. What effect is that going to have on my picture? No one chomping at the bit, I guess. So this is just pointer assignment, right? We talked about pointer assignment. That was like, I don't know, 2.4 or something. Maybe it will point to the location of the array. Right. So remember, the way to think about pointer assignment is, I would read it this way. Make pointer point to the same memory location that my array is pointing to. That's what pointer assignment does. Make pointer point to the same memory location that my array is pointing to. Okay? Anybody want to ask a question about that?
So it's pointing to the address of my array?
No, it's pointing to, I mean, you'll never have a pointer pointing to an address unless it's a pointer to a pointer, right? It's pointing to the yellow memory location. Or in other words, so, you know, if if this cell right here, the yellow cell, was memory location, 1A40, then what's actually in this cell here, we draw it like an arrow, but what's actually there is 1A40, right?
Yeah.
The memory location of that. So when I say pointer gets my array, that just means, just like with any other variable, I'm copying what's in my array and I'm putting it in pointer. So 1A40, right?
Okay.
So it's the memory address. What's being assigned there is the memory address of that yellow cell. But when computer scientists don't actually talk about actual memory locations, they just refer to them as pointers. And so we draw the picture like that.
Okay.
Anybody want me to say that again or say it a different way? Or pretty critical right there. Okay. In that case, I'll keep plowing ahead. So basically what we have here, when I say pointer gets my array, I basically have two different names now for the same memory location. Anything I can say with pointer, I can say with my array, I can interchange them, right? So just to do an example, let's say that I create a new function down here. And let's say I 0, I less than 10, let's just say x of I gets I. Okay, so what this is doing is whatever the argument is that is sent to this function, I'm going to just set every element of that array equal to its index, right? So array, so x of 0 is going to be 0, x of 1 is going to be 1, x of 2 is going to be 2, x of 3 is going to be 3, and so on. So if I call this function, and then print the contents of my array, let me just, for fun, let me just do pointer here. Okay, and then let me make a prototype for that. And then go ahead and take a minute and stare at that. Let me know what's confusing about it. Anything in there that does not make sense. Or any questions about what output that's going to produce? Or anybody want to take a guess at what output that's going to produce? Let's go ahead and run it. Surprise, surprise. The contents of the array are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Raise your hand if you're pretty clear on why that is the output. Ready to move on to the next thing. Not a lot of hands, too. Okay, close enough. I said raise your hand, but everyone's doing thumbs up. That's totally fine. I get that's probably the same thing. Okay, anybody want to admit that like thumbs down, like not really feeling a little clueless, whatever. I won't pick on you. I won't even look at your name. Just curious how we're doing here. No questions. All right.
So why does the function work if you didn't define what it's supposed to take as an array?
Because arrays and pointers are the same thing.
Oh, okay.
Okay, so I guess one thing I could do is let's actually draw a picture of what's going on here. So I already drew the picture of this pointer assignment. Now I'm calling a function named init. So down here, I'm declaring a pointer named x. So this is going to be inits x, right? Everyone understand why I put inits in front of it? I guess I think that should be pretty clear, right? It's a local variable inside the init function. And so that's just a pointer variable. It's a parameter, so it starts off with an initial value. It's whatever value was passed to it. What value was passed to it was whatever was being stored in the variable up here, my array. What's being stored in my array? A pointer to that yellow cell, right? So that means that what's being, x's initial value when I start off this function is going to be a copy of what was in my array, which is a pointer to that yellow cell. So it just means I'm going to have, this might be a little tricky to draw because it's going to go through the other box, but I just have another pointer to that yellow cell, right? That's what inits x is going to be initialized to. All right. So now we're ready to start executing the statements inside init. And so this just says x of I gets I for all of those values. So this is just going to put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Now I'm done with the init function. So this all goes away. And I'm back in main. I'm at line 41, and this is the situation, right? Any questions about that process? Would this still work if you replace my array pointer on line 40? Yep. I'll put pointer there, same thing, right? What goes in the parentheses is what's being passed down to the init function, and my array and pointer both contain the same data, right? They're both memory locations of that yellow cell. So whether I put pointer there or my array there, same thing. I will just run this real quick to prove that to you. Okay. Anything else I should try here? What if I say, what if I change this to that? Same thing. In fact, it turns out this declaration and what I had there before are really just two different ways of saying exactly the same thing. Okay. I think we've done just about every permutation of what we could mess around with here. I mean, I could change this to my array, but hopefully you're getting the point by now that that's just not going to change anything, right? My array and pointer are just two different variables that do the same thing. Any questions? Okay. Last thing I want to do before we move on is I'm just going to tell you the buts. Okay, so this is all true. Arrays and pointers are always interchangeable. They're exactly the same thing. There's just a couple of caveats here. The first one is An array name is actually a pointer constant. Whoa, constant. Okay. So what that means is, if I tried to say my array gets pointer, I would get a syntax error. Can't do that. So if I use pointer notation to declare a pointer, then I can change it. I can say pointer gets something else. I can use the word pointer on the left side of an assignment operator. If I use array syntax to declare something, but call it a pointer, then I can't do that. I can't change the actual contents of my array and make it point at a different memory location. Okay, so that's just one rule. You might want to put that in your toolbox. It's probably never going to come up. It would be very strange if there was a situation where you attempted to do that. But I just putting it out there so you know the whole story. And then the other thing, which you may have noticed, is that when you declare an array, you get an array allocated instead of just an uninitialized pointer. Right? So in a few minutes, I'm going to be showing you how you could actually get yourself an array allocated this way. But at this point anyway, what we're seeing is when I declare an array, I just get an uninitialized pointer. Nothing, it's not pointing at anything. If I want to get an array, the only way I've shown you so far to do that is to use array notation to declare it. Okay, so as far as I can think of, those are the only ways in which the array notation is different from the pointer notation. Any questions about any of that? Okay, so we're kind of changing gears here a little bit. We're gonna be moving very gradually towards something that might actually seem useful. Before we go there, we need to just review a little bit about memory in general. And I think this is one of those times when, whenever I teach this, I try to sort of say it in my own words without reading what I wrote before, and then I end up just making it more confusing. So I think I'm going to actually bring up the lesson here. And we can just go over the first couple paragraphs of this part. So okay. So far we've studied two types of variables in C++. We probably haven't used these words, but the two types of variables that we've at least briefly looked at, even if we didn't call them this, are automatic variables and static variables. Actually, all of the variables that we've used in our programming assignments have been automatic variables. That simply means that when you declare the variable, C++ automatically allocates memory for it. And then when you reach the end of the function, C++ automatically deallocates that memory. To be a little more precise, it's not necessarily the end of the function. It could be the end of some other scope, but just to keep things simple, let's call it when you get to the end of the function, C++ automatically deallocates that variable, it goes away. Okay, that's all of the variables we've been using. There's also this other concept of a static variable. That's just a variable that is in existence for as long as your program is running. So that would be a global variable, or there's also in C++ a way to make a function, a variable inside a function be static, but we haven't talked about it, and we may not. It's kind of a subtle point that we probably won't get to. So anyway, just to let you know, there's those two things. Don't really need to understand that in detail. But the reason I'm saying that is that now we are going to talk about a third way of using memory in C++. Whoa, that's not good. And that's something called dynamic variables. And the deal with dynamic variables is that the programmer has complete control over when the variables are allocated and deallocated. This results in a great deal of flexibility, but it's also a lot more work for the programmer. Automatic variables are allocated in a highly structured area of memory called a stack. So each time a function is called, each time a function is called, new memory is allocated on the stack for all of the variables in that function. And then when control returns to the calling function, that memory is deallocated, so released, so that it can be used for some other purpose. Okay, and again, I'm sort of ignoring the fact here that there are other things besides the end of the function that may cause this to happen, but going with that for now. Any questions about that? That's review. That should not be complicated. If it's complicated, it's probably because I said it badly. Each time a function is called, new memory is allocated on the stack. And then when we reach the end of the function, that memory is deallocated. Okay, dynamic variables are allocated in an extremely unstructured area of memory called the heap. So we've got the stack, which is a nicely organized area of memory. And then we've got the heap, and I don't know why, but whenever I think of the heap, I think of like the pile of laundry in the middle of a teenager's bedroom floor, right? A disorganized area of memory. So when the programmer allocates memory for a dynamic variable, and it'll be using the new operator, which we'll be talking about in a minute, the computer chooses any piece of available memory in the heap to use for that variable. Obviously, then that memory is unavailable for other uses until the programmer explicitly releases or deallocates. I'm not sure why I use the word release, the memory using the delete operator. Okay, so that's just sort of the overall idea of what we're going to be doing here. If it doesn't make total sense yet, that's okay. The idea is just you've got this separate area of memory called the heap, and when I use dynamic variables, they get allocated and deallocated on the heap. Okay, enough of that for now anyway. Let's talk about the new operator. I think I'm going to delete all this and start from scratch. Okay, so let's say I have a variable that is a pointer to an int. So if I want to allocate a new variable on the heap, I say int pointer gets new int. Okay, so if I'm going to draw a picture of that, delete all this. I'm going to draw a, I want to make it thick. Okay, so this isn't very thick, but you can see that there's a border a horizontal, sorry, let me try that again. There's a vertical line there. I'm going to use that vertical line to separate my stack from my heap in my diagrams. I think there's an easy way to make that thicker, right? All right, good enough. Okay, so what I have is over here on this side, I'm going to have my stack. And over here on this side, I'm going to have my heap. And so when I say int start int pointer, that's nothing new, right? That's what we've been doing for a long time. The name of the variable is int pointer, and the variable itself is going to be here on the stack. When I first declare it, it just has jump inside, right? So that's what the picture looks like after that first declaration. Now this line, there's two things going on here in sequence. The first thing that happens is this new int statement. Just a little trivia, probably doesn't matter, but just to be precise. Oddly enough, in C++, that word new, it's not a reserved word like int or if or while. It's actually an operator. It's kind of a funny operator because, you know, most operators aren't words, but it's an operator. So this is an expression. Int is the operand and new is the operator. And what this does is it creates a new variable of type int on the heap. Okay, so that's the first thing that happens with that statement. Second thing that happens with that statement is that the address of this new int gets returned. And so it's going to be assigned to this variable on the left side of the assignment operator. Okay, so that's our picture after those two lines of code. Any questions about that? Other than, I'm guessing as you're sitting here that you're probably thinking, okay, that's great, but when are we going to get to something useful here? So bear with me. For now, just go with, all right, this is something I need to be able to know how to do. Go over what the heap is again. There's really not much to say about it other than it's just an area of the computer's memory. That's pretty much it. And the way it works is that whenever I say new, the computer just grabs a piece of memory from the heap and gives it to me. Okay, so this is all a big picture of the computer's memory. It's just split up into different segments of memory. Okay, let me just give you a couple more details here. It's separate from the other variables. It is a separate area of memory from the variables that are on the stack. Yes, that is correct. I guess it depends on what you mean by separate. It's still all just in the computer's memory, and the runtime environment gets to decide where it's going to divide, you know, which part of the computer's memory is going to be the stack and which part of the computer's memory is going to be the heap. But obviously, they're not the same part of the computer's memory. They're separate parts of the computer's memory. All right, so these two lines, typically, we'll just combine them into one line. Really, this is just the same thing as what we do when we declare an int variable and initialize it. You know, int I gets 0, int count gets 0. Same thing here. We're just combining those two statements into one. Everyone okay with that? No questions? Okay. Okay, so the next thing is, and this may be the first time where we actually get something useful, okay? You can, besides just declaring a single variable on the heap, you can, not declare, that was the wrong word. Besides just allocating a single variable on the heap, you can allocate a an array on the heap. So let's allocate an array of strings on the heap, just to make it a little more interesting. Same exact syntax. I shouldn't say and, I should say string, right? So right now what I've got is, if I leave it like this, I've got a variable called string array on the stack pointing to a single string variable on the heap. But if I just put brackets after it, then I get a pointer variable on the stack pointing to an array of strings on the heap. Okay, so just to kind of fill out this example a little bit. Okay, so what I'm illustrating here is that unlike the arrays we were using before, we could actually ask the user what the size of the array is going to be, and then create the array to be that exact size, or determine how big we want the array to be some other way while the program is running, right? Couldn't do that with the arrays we used before. So this is actually something that we can do now that we can do with pointers that we could not do before we studied pointers. So let's just put some values in. Oh, actually, let me draw a picture of that, right? So this is a variable over here called string array. I declared this variable on the stack, right? That's what this part of the statement is. I'm declaring the variable string array on the stack. This part of the statement is saying, okay, create a new string, create an array of strings on the heap. Let's say the user enters 5 for the array size. So we'll have 2, 3, 4, 5, and then okay, so there's the result of the right side of the assignment operator. And then the assignment operator causes string array to point to this newly allocated array over there. Okay, so notice just one other interesting thing. Notice that the variables on the heap don't have names, right? That's the way it is with variables on the heap. That's why we have to have pointers pointing to variables on the heap, because the variables on the heap don't themselves have names. They can only be accessed indirectly. Questions so far? Okay, so let's actually put some values in there. Let's say star int pointer gets 72. So the effect of that would be to put 72 here. Let's say, how would I put, let's say I want to put the word Nicole here. What would be the C++ code to do that? Someone want to take a shot at it? No one wants to take a shot. Okay. All right. What do you guys think? Everyone think that's correct? Raise your hand or give me a thumbs up if you think that's correct. Anybody thumbs down? Problem with that? Okay, I do believe that that is correct. Is there another way that we could do that? That comes to mind easily? What about this? How many people think that'll work? Thumbs up. Or thumbs down if you don't think it'll work, right? All right, it looks like we're in good shape. That is correct. Either of those two statements will do the same thing. And then what if I want to put the word Ryan over here? Well, that's just going to be string array of 2 gets Ryan. And then let me just print some things out so that we can verify that I'm not lying to you. Okay. While I'm running this, feel free to let me know if there's anything confusing going on here. Okay. Any questions about any of that stuff going on? Okay. So I think that's all I'm going to say about dynamic memory for now. Oh, no, sorry. I've told you about the new operator, but I have not told you how to deallocate this stuff, right? Boy. So here's how I'm going to deallocate. So I need to deallocate this piece of memory right here, okay? When I say deallocate, what that means is I don't need this anymore. So I'm telling the computer they can go ahead and use that piece of memory for some other purpose now. It's free to use. The way that I deallocate this piece of memory over here on the heap is I say delete int pointer. Okay, let me just say that I think that's one of the most confusing things in C++ because the operator there is delete, but you're not actually delete. There's two problems with that, okay? There's two things that are confusing about that. The first thing is you're not actually deleting anything. You're just deallocating something. Another word for deallocate is release, right? I'm just releasing this memory back to the computer so they can use it for something else. So first thing is, don't think of this as deleting the value or something, okay? Second thing that's confusing about this is it's not int pointer that I'm doing anything to. It's the memory location on the heap that int pointer is pointing at that I am doing something with. So just be super, super careful whenever you use the word delete. Stop, think about it, okay? I have students, 2/3 of the way through my data structures class, still thinking that when they say delete int pointer, what they're doing is actually somehow affecting the variable int pointer itself, when it actually has nothing to do with int pointer. It's only affecting the variable on the heap that int pointer is pointing at. Okay, that's a good question. When you say it, I guess the first question is, what do we mean by it? because the only thing that it is releasing is this it over here on the right side. So an int pointer was not declared using new, right? Int pointer is an automatic variable. So int pointer is just a variable that got allocated on the stack when I declared it up here. And then when I hit this closed curly brace right here, it's going to be automatically deallocated from the stack. So the new and delete operators only have to do with the heap. So I guess the short answer to your question is no, just the heap. Did that make sense to everyone? The new and delete operators don't have anything to do with that memory that's on the stack. That's all automatic. New and delete is only working on the memory that's in the heap. Okay, so after I execute this delete statement, all of this, the way we would draw a picture of this, you know, if I'm keeping track on a whiteboard because I'm trying to debug my program or something, is I would probably just erase it, right? That's a little tricky because that kind of makes it seem like that memory location is somehow going away. Really, it's not going away, like I've said several times now. It's just being deallocated, right? So moving on to this array, same thing, except that when I want to deallocate an array that has been allocated on the heap, I just throw some square brackets in there. And that means deallocate the entire array, not just the, you know, just the first element of the array. All right. Any questions about any of that? Okay. Did we actually run this? I can't remember. Let's just, oh yeah, there it is. Okay. I think that's all I have to say about new and delete. Oh, just one more quick thing, I guess. You won't even use this until we get to the last week of the semester, but it turns out that in C++, it's okay to delete a null pointer. If you call delete on an uninitialized pointer, your program is going to crash because you can't call delete on a piece of memory that wasn't allocated using new. But if you have a null pointer, you can call delete on that and it's just a no op. So couple just kind of review type statements. Every time you use the new operator, you're going to have to be watching out and making sure that somewhere down the line, you're going to use a delete operator to deallocate that memory. Okay. Something else that's very tricky about delete. This may be, and there's probably some other subtle example, but I can't think of any. So as far as I can think of, this is the only thing we've studied in C++ where your program will still work if you just leave it out, or sometimes even if you do it wrong. But in particular, if you just never delete anything, your program is still going to work because all the programs we're writing are just these tiny little things, and there's plenty of memory in the computer to just keep using more and never deallocate anything, right? So it's a little tricky because it's the first time where you run your program, you get all the correct output, but it turns out that your code is wrong because you forgot to delete something. So you just have to be careful to watch out for that. Okay, one more quick thing. Got a couple of minutes left here. Let's look at these 5 lines of code and let me know what you think. Okay, let's draw a picture of what's going on here. So I'm starting from scratch. Okay, so I've got a variable here on the stack named pointer1. I'm calling the new operator to create the new int on the heap. And then I'm setting pointer1 equal to that new int. Or I guess I should say I'm setting pointer1 equal to the address of that new int. Okay, that's the first line of code. Second line of code, pointer2. Same exact thing again, right? Right, and both of these currently just have junk in them. Okay, that's the first two lines. Third line, star pointer2 gets 44. So when I say star pointer2, that means that cell? Well, if it weren't for the star, yeah. But because the star is there, that means I don't mean this cell, I mean this one over here. Follow the arrow, that's the cell I'm talking about, right? It's kind of funny that I'm calling them cells. I'm only calling them cells because we're in Excel. Normally I would say memory location, okay? Okay, so everyone clear on that? When I say star pointer2, that's referring to that yellow cell, that yellow memory location. So I'm saying star pointer2 gets 44. So my 44 goes there. Everyone okay so far? Yikes, not mean to do that. Everyone okay so far? So now I'm on this fourth line here. Star pointer1 gets star pointer2. This is where you need to be really careful. And if we had a couple more minutes, I'd probably try to make you have you work this out first to see if you get it right. A lot of students get confused here between whether we're talking about the pointer or whether we're talking about the memory location that the pointer is pointing at, right? So here I'm saying star pointer1 gets something, right? Put something into star pointer1. Well, which of these four memory locations is star pointer1? It's this one, right? This is pointer1. So this is star pointer1. So since we're focused on that, I'm going to make it the yellow cell, the yellow memory location. Okay, so that yellow memory location is star pointer1. Next question, what is the value being stored in star pointer2 right now? $44, that's correct. The value being stored in star pointer2 is 44. So what this is saying is take that 44 and put it up here in this yellow cell. Okay, so now I've got the 44 in two different places. Next thing I'm going to say, and part of this example is being able to distinguish between when I'm talking about the pointer and when I'm talking about the memory location on the heap that the pointer is pointing to, right? Now I'm saying pointer1 gets pointer2. That's pointer assignment. So that means whenever you see pointer assignment, translate it into this. Make pointer1 point to the same memory location that pointer2 is pointing at. So in our picture, that means this, right? Any questions about those 5 statements and how they get translated into the picture? Okay. Anyone see anything about the current state of our computer's memory that is bad? I just noticed I completely missed a question earlier on, and I think it's too late to answer it now. Sorry about that. Anybody see anything about this picture? The space is still allocated on the heap. Right, so now we have this variable here with the 44 in it. And not only is it still allocated on the heap, there's no way for us now to deallocate it. That memory is lost to us forever. Sorry. So this is called a memory leak, and that's really what I've been getting at here. Okay, so memory leaks is just something that you want to avoid. What we should have done is, before we reassigned pointer 1 so that it pointed down here, we should have deallocated that yellow memory location, right? So delete pointer 1. Once I do that, then I can say, all right, this is now deallocated in my picture. I might indicate that by just deleting it. Okay. Ooh. Yeah. All right. Any questions about any of that? The only other thing I'm going to say is that this actually illustrates an important point, and I wish, there's probably, I've probably said this 100 times, and you have a long list of things that fall into this category, but I'm going to say, if you could just make it a rule for yourself that every time you use pointer assignment, you better think hard about whether the memory location on the heap that left pointer variable is pointing at needs to be deleted first, right? Or to put that in a simpler way, just every time you use pointer arithmetic, think hard about whether there should also be a delete. Okay, usually there will be, unless the only time there wouldn't be is if there's some other pointer already pointing at that, so you're not going to lose it. Typically, if you have a pointer assignment, you're probably going to want to have a delete first. Okay, I think I'm done. Any last minute questions before we wrap it up? All right, then have a good lab. Hope you enjoy it. And I will see you next Monday.
Thank you. Have a great day.